Components. Components are the building blocks of any React app. They are like JavaScript functions that accept arbitrary input props and return React elements describing what should be displayed on the screen. Everything on screen in a React app is part of a component. Essentially, a React app is just components within components within components. So developers don't build pages in React, they build components. Components let you split your UI into independent, reusable pieces. If you're used to designing pages, thinking from a component perspective might seem like a significant change, but if you use a design system or style guide, this might be a smaller paradigm shift than it looks. Props. Props are a short form for properties and they refer to the internal data of a component in React. They are written inside component calls and passed into components. They also use the same syntax as HTML attributes, i.e. prop equal value. Two things worth remembering about props are: first, we determine the value of a prop and use it as a part of the blueprint before the component is built. And the value of a prop will never change, i.e. props are read only once passed into components. You access a prop by referencing it via the this property that every component can access. So essentially, a prop is really a state as well, but it's state of a parent. And it uses the this, kind of like with the this accessing a method within the class. So the difference, a component is really accept an arbitrary input, a props, and return a React elements. So the component is what receive a props, or like it's a tree structure where you have a parent and a children, where that children is actually a component that receive a props from a parent. So it inherit a state and then return basically an element of UI that is returned in the front end. So state is an object that holds information that may change over the component's lifetime. So the components, the children parent, and then the parent of that parent, those could change depending on the interaction of the user and the data in the system. So it is the current snapshot of data stored in a component's props. So it's the current snapshot. So the state is really where the revision came from, such as the state or of this thing at this time will be reverted. But sometimes you also can revise depending on the action, the state of action. Your but it's still tightly related to a time or a state where at this specific time this action happens, such as save drop, then you revise to that version. The data can change over time, so techniques to manage data changes become necessary to ensure the components looks the way engineers want it to. Just the right time. This is called state management. Application structure for React.js. When building small happy projects or trying a new concept or library, developers can start adding files to a folder without plan or organizing structure. This could include CSS helper components, images, and pages. A single folder for all resources becomes unmanageable as the project grows. Any respectably sized code base should be organized into an application folder structure based on logical criteria. So just like with semantic structure of language, just like with anything else, we need to be aware of the trade-offs, or we need to be logical about our decision on what we are making. So a logical because that logic helps to keep our decision reasonable. So the decision on how to structure your files and application components could be a personal or team choice. It would also depend on the domain and technology used. So it also depends on the business, the technology used in the business. Introduction: React.js itself does not provide a guideline on structuring projects, but does suggest a few commonly used approaches. Let's look at this and understand their pros and cons before discussing folder structures for projects with added complexity and Next.js application. At the high level, you can group files in a React application in two ways. Group by feature, create folders for every application module, feature, or route. Group by file, create folders for different types of files. Group by module, feature, or route. In this case, the file structure would be would mirror the business model or the application flow. For example, if you have an e-commerce application, you will have folders for product, product list, checkout, etc. The CSS, JSX components, test, subcomponents, or helper libraries explicitly required for the project module reside in the product folder. So this is what most people intuitively think when they are trying to look at a folder, because they want to see how the application flow by looking at the folder. But that has an advantage and disadvantage, just and not always going to work in all applications, especially for complex ones. So the advantage of grouping files by tutor is that if there's a change to a module, all the affected files are collocated in the same folder and the change gets localized to a specific part of the code. The disadvantage is, since you did not separate it in common functionality, you have to do a periodic categorization of similar logic. Group by file type. In this type of grouping, you would create different folder for CSS components, test files, images, libraries, etc. Thus, logically related files would reside in different folders based on the file type. The advantages of this approach are you have a standard structure that you can reuse across projects. Newer team members with little knowledge of the application specific logic can still find files for something like style or test. Common components such as date pickers and styles imported in different routes or modules can be changed once to ensure that the effects is seen across the application. You reduce the need to search for the specific functions or export functions in the search bar of your developer chosen IDE. So because you use a specific file type, you reduce the need to go to search, because you just need to go to that specific file folder. The disadvantage are a change in logic for a specific module would likely require changes in files across different folders. As the number of features in the application grows, the number of files in different folders would increase, making it difficult to find a specific file. See, either of the previous approach could be easy to set up for small to mid-size application with a small number of files, like 50 to 100 per folder. For larger projects, however, you may want to go for a hybrid approach based on the logical structure of your application. Hybrid grouping based on domain and common components. Here, you would group all related components in files in all of your folders in components folder. Corresponds to collocating related files in all your application flow specific routes or features in a domain folder. The name could be domain, pages, or routes. Every folder can have subfolders for specific subcomponents and related files. Depending on the complexity of the application, you can modify this to a flatter structure without subfolder or a more nested structure.